Daylight. There's nothing quite like the rising sun to get you ready for your day. And when it enters your home, it can transform a dingy room into a vibrant and relaxing space. The warmth of the sun itself, in combination with the fresh blue tones of the sky, bring a vivid and lively feel to the light, making it utterly unique and something to be treasured. However, despite appearances, this is not actually early morning sunlight. To tell you the truth, it's actually nighttime, and this is an artificial sun. And in this video, I'm going to be showing you exactly how to build one. Everything you see here, from the accurate parallel shadows to the natural blue sky scattering, and even an apparent space of infinite depth behind the window, is all down to a unique design that can even be made out of recycled parts. This is going to be a good one. This video is sponsored by KiwiCo. More about them later. Making a convincing artificial sun does present a few challenges, the first of which is throwing the light source back so that it appears to be at infinity. You see, as the sun is so far away, when its light rays reach Earth, they are practically parallel, which is one of the reasons for the sun's unique illumination characteristics, like shadows that don't change in size. Interestingly, recreating these parallel rays with a local light source isn't particularly difficult, as we can just use a lens. You see, when the lens is placed in front of the light at the lens's focal length, it actually collimates the light rays, which means that it makes them parallel. These newly collimated rays now have some of the characteristics of the sun, namely that the light intensity doesn't change because of distance alone, and shadows don't change in size either, which is super interesting to see. Another fascinating result is that anything at the lens's focal point appears to be pinned at infinity, and appears the same size no matter whether you're close to it or far away, as we observed in my recent DIY projector project. So, success, right? Well, to a degree yes, but the diameter of your lens directly dictates the size of your area of projected sunlight, so you need a massive lens to really get the best out of it if you're using a single point light source. And even if you use lenses of the Fresnel variety, this can get pretty expensive, and you still have some issues to contend with, such as chromatic aberration, which is the rainbow effect you see at the edges. Thankfully, however, there's another way of collimating light rays, which is to use a parabolic reflector. Now this, just like a lens, can take light rays emitted at its focal point and bounce them back, but in a way that collimates them to be perfectly parallel, only this time without any chromatic aberration or distortion. Nice. Reflectors like this are just as expensive and hard to find as large lenses, however, or so you might assume until you realise that there might be one already attached to the side of your house. That's right, satellite dishes too are parabolic reflectors, intended to amplify distant radio signals by focusing them onto a single point. They're often off-centre designs, which is why they're frequently oval shapes rather than round. The best part about utilising these though is that used ones can be had for very cheap, or even free if they're old and need replacing. I'm using a big one here that measures 1.2 meters in diameter, which means that my area of projected artificial sunlight will be the same size as this. However, as you can see, it isn't reflective to visible light, so that's the thing we're going to have to fix first. One important thing to do before proceeding, however, is to give it a good clean, as this will get any dirt off, which means that it will be much better for the next step. If yours is super rusty like this one, you'll need to give it a thorough sanding down before applying a rust covering primer. Both of these prepping processes are important because we're going to be using vinyl mirror effect film to give it its required reflectivity, and we're going to cut it into strips so that it's easier to apply. Now you might be tempted to use some reflective foil tape here instead, but from my tests the mirror film is significantly more reflective, so is definitely recommended, and you can find links to some in this video's description. It does take quite a while to stick on in strips, but once done you should have something that looks like this. With it now mirrored, it's rather ironically very important to stop any sunlight from ever hitting it, as it could focus this light to a point and start a fire. So be careful. So this is looking really promising, but before we can test it out and see whether it's going to successfully collimate light rays, we need to sort out a light source. For this, we are going to be using a high power LED, and as usual, I recommend that you get one with a CRI of a minimum of 90, but ideally 95, and a colour temperature of 5600K. Now, as these LEDs are so powerful, they do generate heat, which means that they have to be used in combination with a heatsink. Now, thankfully for 100 watt emitters, you can get away with using a computer heatsink, which are super cheap to buy second hand. But for this project, I thought I would go with something a bit more special, and I'm using a 500 watt LED from UG LED. And this is obviously very bright, but also it gets hot. So its accompanying heatsink is unfortunately way oversized, very heavy, and very loud as well with the internal fan. So instead of using this massive heatsink, which would probably bend the satellite dish's support arm, I'm going to be instead water cooling the LED. And the set of components I have here are from AlphaCool, and I'm going to be introducing them and their function as I go along. The first component we're going to utilise is a water block, which internally has a lot of tiny fins that the water rushes through, taking heat away from the bottom plate. To interface this well with the LED and ensure good heat transfer, some thermal compound can be used, and then the whole thing can be clamped together with a custom bracket. Now, this is actually going to be mounted in place of the satellite's original receiver. So after removing the original receiver, a small bracket can be made out of a short length of aluminium angle, which allows the LED to be mounted in place of the original receiver at the same position and angle. If you're using a lower power LED and just want to use a heatsink, this process is pretty much identical, and to power the LED you can just use a voltage regulator and an AC adapter. And this is a very good low cost way of getting a lot of light output. However, as I'm using a much more powerful LED and water cooling, the process is a little bit more involved. And to get water to and from my LED, there are some standard plumbing fittings on the back of the water block, which allows some compression fittings to be used to securely mount some rubber tubing in place, which can then be routed down the arm along with the LED's power wire. Now, as the power supply I'm using for my LED is super solid and heavy, not to mention waterproof, I made some custom brackets to mount the pump and reservoir combo unit directly to it, followed by the radiator. And this can be hooked up to the pump's inlet using a short length of tubing. The pump's outlet can now be connected straight up to the LED's water block and then returned through the radiator, completing the loop. So the last thing to do now is to fill it up. This process can take a while as it needs to be done bit by bit, running the pump in bursts to push the water into the loop. If you ever do this yourself, be careful to never run it dry, as it relies on water for lubrication and it will likely get damaged if it's run without water in it. So with water rushing through now without any air pockets, some fans can be added to the radiator and the LED is ready to try out. Honestly, I forgot just how bright this LED is. It's pretty incredible for being a single light source. But now it's time to mount it onto the satellite. To make a support for this, I screwed some pieces of wood together to make a triangular shape, which made it fairly easy to lift the satellite dish up into position. So as you can see, I've actually mounted the satellite dish upside down, and this is so that we can get a steeper angle on the light output, so it appears like it's coming from the sky and not the ground. And there are some really promising results actually from the reflection coming off the mirror, because the LED itself appears to stay the same size. So that does indicate to me that it is actually collimating the light. But we're really just going to have to try it out and see whether it works. So I haven't actually tried this yet, so I'm a little bit nervous. Right, are you ready? Here we go. Okay. Whoa. Oh wow. Okay, you can't see this because you're probably blinded by the light, but yeah, let me show you. As you can see, we have got parallel rays. If I move my hand closer to the wall, its shadow doesn't change in size, no matter where I am in the room, which is pretty impressive. Now if I look in the general direction of the light source, it does look like it's at infinity, which is super impressive. I can't look at it directly because it is a bit too bright, but just looking in the general direction of the satellite makes it seem apparent that it's in the distance, which is super cool. And what's more, it's absolutely pouring with rain outside, which might seem irrelevant, but the thing is, it's all sunny in here. For a bit more space, I've actually moved the satellite dish out into the hallway, and as you can see, the effect is really quite remarkable. This feels and looks just like daylight, and looking at the light, not directly of course, through the door, it does appear to be extremely far away, so mission accomplished. But there is one thing missing, which is of course the blue sky effect, which is fairly significant because the sunlight look will only properly come into fruition when the sky adds soft blue illumination to the room. So that's the thing we're going to have to sort out next. But before we get on with that, it's time for a quick ad from this video's sponsor, KiwiCo. KiwiCo makes super cool hands-on projects and toys that are not only fun to construct, but they're also very educational, as they've been designed to introduce kids to concepts in STEAM, which is science, technology, engineering, art and maths. So they're a great resource for learning with at home. Each one contains everything you need for each project, so it's completely self-contained, with detailed kid-friendly instructions and an educational magazine filled with content to learn even more about each grade's theme. Now personally, this kind of thing is right up my street, and I've said before that younger me would have absolutely loved kits like this, as learning in a hands-on way is far more interesting and far more engaging than learning, say, in front of a computer screen or from a textbook, and it has a whole different creative thought process that you learn from it. They offer 8 subscription lines, each catering to different age group brackets and also different topics. And you can either go with a monthly subscription and get a new box every month, which you can cancel at any point, or a single gift, which is great for birthdays and special events. And what's more is that if you go to kiwico.com/DIYperks50, you get 50% off your first order of any crate, which is brilliant value, especially with the holidays coming up, as they'd make great gifts. So thank you KiwiCo for sponsoring this video, and don't forget to check them out with the link below. So thanks to the satellite dish, our artificial sun is now at infinity, reproducing parallel rays that look and feel like sunlight. The real challenge for this build, however, is going to be mimicking a blue sky. You see, the reason why the sky appears blue is because molecules in the Earth's atmosphere actually bounce some of the light rays that are coming in from the sun off their initial path, which is a process known as Rayleigh scattering. As this has a greater effect on shorter wavelengths, blue light gets scattered quite a bit, while red light, for example, can pass through without being affected as much. This results in some of the white light from the sun diffusing into what we see as blue sky, leaving the sun itself to look more yellowy and warm as a result due to some of its blue light being scattered outwards. A great experiment for observing a similar effect at home can be done by getting a glass of warm water and dipping in a little bit of soap. As the soap dissolves into the water, it begins to scatter light in a similar way to the sky, making it look somewhat bluish. Looking through to a light directly behind it results in the light appearing more orange because a lot of its shorter wavelengths are getting scattered. This smaller scale phenomenon is known as the Tyndall effect, as it relies on much larger particles compared to Rayleigh scattering and can be seen in common materials such as HDPE milk cartons and opalescent glass. Now, one of the best ways of achieving this effect would be to use nanoparticles mixed into some sort of epoxy resin. However, despite a ton of research, I haven't been able to find a good source of nanoparticles that work as well as this. So if you guys have any suggestions, do let me know in the comments down below. But for this project, my conclusion is that the best way is to simply use soap and water, as it's simple, safe and effective. However, how are we going to get water into the shape of a window? Well, we're just going to mimic a fish tank. For this we'll need 2 sheets of tempered glass, and I suggest using an online calculator to work out what thickness you need for the size of your window. While it would be possible to glue these together with a spacer to make a 4mm deep watertight chamber, I'm instead going to be using a gasket and clamp the 2 pieces together with some 3D printed holders along with some washers and bolts. The plan here is to mount it directly to the back of a sheet of MDF, which has been painted to match the wall colour so that it blends in nicely around the door frame, with the satellite dish behind it in the hallway. Watching for any leaks, some distilled water can now be siphoned into the chamber, making it ready for our soap mix. I ran out of distilled water at this point though, so instead I used filtered tap water. This does increase the likelihood of soap scum forming after a day or two though, which will need to be filtered out in a couple of passes over a couple of days. Though this would be good practice to do even if you used distilled water here. And you may want to add a drop of biocide if you're going for extreme longevity. With the mix ready, it can be injected into the window with a plastic syringe. Look at that! As the soap enters the chamber, we can observe it instantly scattering the light from an LED I placed behind the glass. When you're doing this, I do suggest that you use the proper artificial sunlight to preview this instead, but I wanted to leave it for a big reveal. Over 24 hours, the soap mix will spread out and become evenly distributed, so why not in the meantime finish the scene off with some light curtains to make it look a bit more authentic. Right, are you guys ready? Here we go. Whoa! Look at that! Look at that! That really does feel like daylight. Goodness me! With the blue sky in place, the light suddenly becomes full of life and vibrancy, thanks in part to the sun taking on a warmer hue due to the scattering, with the rest of the room being lit softly by cooler blue tones. This has a dramatic effect on the overall feel of the light, and it now genuinely fools your brain into thinking that it's seeing, specifically, early morning sunlight. Both the parallel rays and their subsequent scattering are necessary for this effect, and neither will work without the other, so it makes for a perfect combination. Now, one of the most remarkable things about this light, I would say, is the way it makes you feel. It's actually nighttime right now, and it's so close to real daylight that it's completely fooled my brain, and I feel fresh and awake, and I'm doing the editing right now, so that's kind of important. But I would imagine that something like this would be really helpful for people with seasonal affective disorder, which is where people feel really depressed in the winter months where there's not much sunshine. And you know, this being basically the same as real daylight should really boost people's moods. So it could be quite useful in that kind of situation, I'd have thought. But even just for a normal person, it just feels so vivid and full of life that every home should have one of these, especially in the long winter months, because honestly, it's incredible. I wish I could convey it enough to you, but hopefully my enthusing about it has done that. But you really do have to see it in person to truly appreciate it, but it's truly remarkable. Photographers and filmmakers would also benefit hugely from a light like this, as I know that for my own work here on YouTube, it's going to be a real help to my filming. So this is without a doubt an incredible build. However, it is somewhat large, and while this wouldn't be a problem in a commercial environment or if you've got a particularly large house, I realise that for most of you, building something like this would be somewhat impractical. However, by taking a few compromises, we can make it significantly smaller. Now, interestingly, this compromise actually results in a few advantages as well, namely that it's much simpler to build, requiring only basic tools. And this all stems back to earlier where I mentioned Fresnel lenses and that they would have to be really big and expensive to work with a single point light source. And while that is true, what we can do is divide it into a grid and use multiple light sources and multiple Fresnel lenses in the form of super cheap magnifier sheets. And because they'll all be emitting parallel rays, they can work together to achieve a very similar effect. Achieving a blue sky will be possible too, again going along with a compromise to make it much simpler to do. So let's get to it. Before starting, we need to take a measurement of the Fresnel lens's focal length by using it to project the real sun onto a rock to be as small as possible, and then measuring the distance. With this measurement in mind, we can now cut some foam board into lengths that match it, with the goal being to make the sides of a box. Each of these sides needs to have some light blue vinyl wrap adding to them, which is for the blue sky effect. Once you have 5 of these panels, the central one of which must have a hole made in it, they can be stuck together with some tape to make the box out of them like so. The next thing we'll need is a 10-watt LED, and in my case I've already mounted this one onto a heatsink with some thermally conductive glue. Once wired up, the LED can be powered from a voltage regulator, and I've got a whole video about how to set this up correctly in the description. Now, dabbing on some hot glue onto the heatsink's legs, it can be squashed against the outside of our box, with the LED showing through the hole that was made earlier. With the LED being completely unfocused, its rays are not at all collimated, so they diverge outwards as you can see. As soon as the magnifying sheet is placed on top, with its ridges facing outwards however, things get pretty weird. As its distance to the LED matches the lens's focal length, the LED is collimated and thrown back to appear to be at infinity, which is why the unlit LED in this shot seems to be far down underneath the floor, and why it doesn't appear to change in size. These collimated parallel rays exit the box and don't diverge, which is why its throw doesn't change in size either, and why objects can't easily block the light projection. Looking into this box reveals that we have a pretty decent blue sky effect, although we can see some lens flares from the Fresnel which does spoil the effect quite a lot. When you're not looking straight into it however, it's remarkably effective for such a simple and cheap build, and it has all the major elements of the satellite version with only a few compromises. Here for example you can see the gentle diffuse blue working together with the main projection of warm light and how it varies depending on the surface it lands on. The idea with this design is to make multiple copies of them so that they can work together in tandem, and you can scale things up to be as big as you like. Alignment will never be perfect though, and you can see some crossing over where the chromatic aberration causes some rainbowing. But shadows are consistent, which is very nice, and taking a look into the units themselves shows how the virtual sun is passed from one unit to the next depending on where you're standing. Very cool indeed. They can even be mounted together at an angle and hung on a wall to achieve a steep projection, mimicking the summer sun. So while it isn't at all as refined or as bright as the proper satellite version, it still has a very similar effect, and considering the effort involved, it's absolutely worth it. Anyway, whichever version you choose, you'll be amazed by the results, and the satellite version in particular works phenomenally well and will provide sunlight on demand for years to come. So I hope you've all found this video interesting, and I hope my enthusiasm about this artificial sunlight has come over sufficiently enough, because it really is incredible and it's been such a long-standing idea that I've had in my head that it's just so wonderful to see it come into fruition, and I hope you agree that it was worth the wait. So many thanks must go out to every one of you for watching this video, and if you enjoy my content, please don't forget to subscribe. And if you want to support the channel financially, you can find the channel's Patreon account at patreon.com/DIYperks, and many thanks if you decide to support me on there. But other than that, I'm Matt, you've been watching DIY Perks, and I hope I see you next time. Goodbye for now. So good.